Hi, in this video we're going to do problem 7.7 in Kellison's book. Second edition of the Theory of Interest looks like this. We're going to be finding and comparing the percentage change in the prices of two bonds. These bonds are both redeemable at par, which is a pretty typical thing. They're currently priced at par. That's very rare. When market yield rates increase, evidently they're a certain level where these are priced at par, they're going to increase. You should know that when market yield rates increase, that causes the price to go down. We're also going to just find and compare those actual percentage changes. I will also take the opportunity in this video to review what we saw in video number 101, a new formula for the price called the premium discount formula. All right, so we've got two $100 par value bonds, both with 8% coupon rates payable semi-annually, currently selling at par. Again, that's a very unusual thing. Bond A matures in 5 years at par. Bond B matures in 10 years at par. These are redeemable at par. That is pretty typical. If prevailing market rates of interest suddenly go to 10% convertible semi-annually, find the percentage change in the price of Bond A, Bond B, be finding that percentage change, and then also justify from general reasoning the relative magnitude, how far from zero the answers are to A and B. Now, in looking at this problem, you might scratch your head a little bit and wonder, well, what are the current yield rates? We're not told that. Do we have to solve for them? It turns out that if a bond is redeemable at par, as they often are, and if it's currently selling at par, that actually means the yield rate is the same as the coupon rate and vice versa. If the bond is redeemable at par and the yield rate is the same as the coupon rate, the bond will be priced at par as well. If you didn't know that, that's something to put away in your memory. We can certainly check it here. Let's go ahead and write down your basic formula equations of value for these bonds. Bond A and Bond B. The basic equation, the basic formula, pricing formula is P equals FRANJ plus C V sub j to the n power. We are in a situation that is common where F equals C. Let me just say that. If F equals C, then I can replace that F by C. I can write this as CR ANJ plus C times Vj to the n. We are in that situation here. Bond A's equation of value would be 100. The price is priced at par. Equals, what are the coupons going to be? 100 times 4% will be 4. That's F times R, same as C times R. This is maturing in 5 years, so that's 10 half years. The number of periods is 10. We could call the unknown yield rate, semi-annual yield rate, JA. It's redeemable at par, so we have 100 that gets discounted back in time, 10 periods. That would be the equation of value, which you can't solve analytically for the unknown yield rate as it stands, though you actually can with this particular example. So you might then go to your calculator and see if you can use the financial functions to solve for that unknown yield rate. So the number of periods here is 10. That goes into n. The present value, which you think of as what you pay out, you think of as negative 100, that goes into PV. The coupons are 4. Those are coming back to you. That goes into PMT. The $100 redemption value goes into the future value. We can compute the interest per year, which is really an interest per half year here. Interest per period is 4%, just like I told you it would be. I told you that when the bond is selling at par and when F equals C, when it's redeemable at par as well, the interest rate will be the same as the coupon rate, 4% per half year. Would that happen with bond B as well? Well, it must, even though the term is different. I won't bother writing down the equation of value. Maybe I'll just put a ... except n would equal 20. Do the same thing with your calculator, except make n equal to 20. Plug in 20 for n. Plug in the same other numbers. Present value as a negative goes into PV. Coupons 4 goes into PMT. 100 future value, redemption value goes into FV. Compute interest per period, you still get 4%. That's got to happen. What this is showing is that when a bond is redeemable at par and when it is currently selling at par, that R equals J, the redemption, the coupon rate equals the yield rate, and this price is actually independent of N. So it's 4% in both cases. J then is going to increase to 10%, or excuse me, to 5% from 4%, half of that. The price should go down from 100, which you already knew. We want to now find how much. We want to find the percentage change in price. After I go ahead and do that, we can justify from general reasoning relative magnitude of the answers, but we can also look at the formula for the price in terms of that new formula, the premium discount formula. So we'll do all that. That's the plan here. So let's go back to bond A. So the yield is now increasing from 4% to 5% per half year. What will the price be in this new situation? It should be smaller. The yield is going up, the price should go down. Put 0.05 there. 0.05 there. Go ahead and compute this. 1.05. Take 1 over that to get V. Raise that to the 10th power. Subtract from 1. Divide by 0.05. Multiply by 4. The present value of the coupons is 30.89. Store that in register 1. Present value, the redemption amount, 1.05. Reciprocal, there's V, raised to the 10th power. Multiply by 100. There's the present value, the redemption amount. Add to what's in register 1. The price is now $92.28. What percentage decreases that? It went from 100 down to that. The percent change is what they asked for. Would be negative 7.72%. What about bond B? Difference is N is now 20. The yield rate is now not the same as the coupon rate. We should not expect, as it happened with bond A, we should not expect the price to be par anymore. It's going to go down. It's going to be priced at a discount in both of these situations. Actually, let me do part C right now before I compute this. What's going to happen now is N goes from 10 to 20. Well, the present value of the coupons is going to go up. You've got more of them. But the present value of the redemption amount is going to go down. It's further in the future. However, that is a much larger amount, 100, than the coupons are, 4. Probably the amount this goes down by is going to be greater than the amount this goes up by. Probably bond B is going to be priced lower, and the percentage change will be greater going down. Let's see if that really happens. That's my general reasoning answer to part C. 1.05 reciprocal to the 20th power now. Subtract 1 from 1. Divide by 0.05 times 4. That is a bigger present value for the coupons. There's more of them. Store that in register 1. This goes down, but does it go down enough to make the sum smaller? I believe it does. 1.05 reciprocal to the 20th times 100. Add to what's in register 1. Yes, that is now a smaller amount, $87.54. The percent change is bigger in magnitude, further away from 0. It would be, what, negative 12.46%. more negative. The relative magnitude is larger, and it is negative. A negative change, meaning it goes down. All right, let's spend a few minutes now also talking about how to think about this through the premium discount formula. Premium/discount formula that I introduced in the last video, video number 101. It's a formula that looks like this for the price of your bond. If the bond is redeemable at par, if F equals C, we can replace that F with C. And we can also factor the C out to write it like this. And you see from this formula, which again I mentioned can be easily derived from this formula. I talked about that in the last video briefly. You could replace, let's see, I think it was this A and J, no, this V to the N with 1 minus J, A and J, and then do some rearranging to get this formula. Okay, and that would be an exercise for you to do. Actually, if you don't replace F with C to get this formula. So that's an exercise you can do. And once you've done that, it's real easy to see why when F equals C, as it does here, and when R equals J, why the price of the bond is the same as the redemption amount, because that thing is going to be 0. And if the yield rate increases, if J now becomes bigger than R, as it does here in this example, it's going from 4% to 5%, then this thing becomes negative and the price goes down. You get C plus a negative number, the price is going to be lower. And when n is larger, as n gets larger, this thing gets larger. As n goes from 10 to 20, this thing increases. But if this is negative, as it is in this problem, when n is larger, that's going to make this thing a negative number further from 0, bigger in magnitude. So when you have C plus that negative number that's further from 0, it will go down more. Bond B's price went down by more. So that premium discount formula is a nice way to think about what went on here in this problem.